Good morning, folks. This is Jonmichael Hands. I'm co-chair of the SNIA SSD SIG, and today I am representing SNIA, as well as I'm the treasurer and secretary for Circular Drive Initiative, a 501c6 nonprofit dedicated to the sustainability and storage. My day job is a senior director of product planning at FADU, and I'm going to let Shruti introduce herself.
Yeah, hi everyone. This is Shruti Sethi. I'm part of the leadership team at Open Compute Project for OCP Sustainability Chapter. And I am also, my day job is a senior PM at Microsoft Azure Cloud. So I'm here from the sustainability aspect, as that is an important focus within, OCP as well as within Microsoft.
So there's quite a bit going on in Open Compute Project around storage, security, and sustainability and how they intersect. And so we are going to give you guys an overview of that. Shruti is going to start with the OCP.
Yeah, let's begin with that. Okay, so before we get into the circularity aspect and how OCP and CDI, the Circular Drive Initiative that Jay mentioned, how all of these industry forums are working towards it and how it can help. Before that, let's have a very brief look at what is the problem that we are addressing over here. So what we show over here is that the total carbon cost of any of our data center devices, equipment, has two major components over here. The first one on the left side, embodied carbon, and the one on the right side, operational carbon. So embodied carbon is essentially coming from the material source, the manufacturing process, transport, installation. So the entire creation of the device becomes a major factor into embodied carbon. Operational carbon comes from the use phase, which is essentially because of the power usage, right? Now, on the operational carbon side, we have certain levers in order to help carbon. And I'm actually talking about using renewable energy. So that can help us quite a bit. But on the embodied carbon side, the left side over here, it is harder to sort of help this part of carbon or reduce this part of carbon as it does not have very straightforward levers. But there is one thing that can really help this left portion, which is embodied carbon. And that is where we come to circularity. Reuse or circular economy, so reuse of devices, can really help the embodied carbon portion, because essentially it is preventing manufacture of unnecessary number of exaggerated number of components while there is still life left in the older components. Okay, with that context set, let's look a little bit at how Open Compute Project, that is OCP, ties into this work and what's the main focus for OCP. So I'll first talk about the three main focus areas of OCP right now. The very first one is carbon transparency and reporting. And this is essentially saying that first and foremost, we need to accurately measure and represent the carbon for different devices, equipment, systems. Because what you cannot measure, of course, you cannot improve. So that's this first focus pillar. The second one is concentrating on circularity and reuse. This is the one that we will dig deep into in the next few minutes. It's basically all aspects around enabling device reuse in data centers. And the third one here is efficiency and interoperability, which is to do with essentially power telemetry, visibility of the power usage, as well as metrics that help us understand efficient usage in the system's devices. Maybe I'll actually go into the depth of what is shown here one by one in the next slides. All that this slide is actually showing us is what is the particular work going on in each of these focus areas. So let's just jump into the next slides and see that. So the very first focus pillar, we'll talk briefly about this, which is the carbon transparency and reporting. Open Compute project actually has a partnership with iMasons, Infrastructure Masons, which is also the iMasons Climate Accord program. And they partner with them to drive a standardized carbon disclosure form so that carbon information can be exchanged in a more standardized format and can be comparable. The other part of this focus, so one part is this disclosure form or label for making it very easy to visualize. I can also call it a label. That is one part of this work. The second part of the work, which you see at the top mentioned as LCA standardization, that is essentially driving to get to a product category rule for data center equipments. That would help the actual assessment of carbon. So the actual method that is used for LCA, which is lifecycle assessment, to get to the carbon numbers. Because I think one current problem in the industry is the discrepancy between the carbon numbers coming from one person's evaluation and a second person's evaluation, or one organization evaluation and the second organization's evaluation. There's a discrepancy in the carbon numbers resulted from that. And it's basically coming because the method of evaluation is not standardized. So the product category rule that we point out, also mentioned in the last statement here, would actually help standardize that. So this is all the goals that OCP is right now trying to target around the carbon transparency and reporting. We briefly show over here, all the major players that are involved in as workstream leaders trying to drive this entire carbon transparency and the product category rules, standardizing how the carbon assessment is done. Oh, yes, they have put out already a first draft of supplier carbon disclosure form, or I'll say carbon label, a first draft of that in order to get feedback. So if you would be interested in having a look at that or providing feedback, please visit the Open Compute project site and you can join in and receive all the notifications to review these documents. Okay. Now we'll jump into our most important topic for this hour, which is the focus on circularity, the reuse of drives. Open Compute project does have partnership. We are working very closely with the Circular Drive Initiative, and JM will talk more about these activities from CDI's point of view later. But there are essentially two aspects being targeted under this focus pillar. The first one is to help data sanitization. And this comes in when we are looking at drive reuse, essentially. There is a concern in the industry about the secure reuse of drives, just from the point of view of data leaks happening, the older data being successfully wiped out of the drive before a second life is deployed. The other aspect that is targeted is carbon accounting for circularity that you see at the top right box. And carbon accounting is essentially seen as a need in order to make sure that there are incentives for everybody in the value chain to enable this circular reuse. Of course, without an incentive, it would not make sense for the various players that have to do their part. It would not make sense for those players to be enabling reuse. So getting deeper into this circular reuse, we look at four aspects that get considered to enable drive reuse, particularly here. And like I mentioned, the very first thing, especially when it comes to drive reuse, is secure data sanitization. So OCP is looking at raising the confidence with data sanitization, not only within OCP sustainability, but other domains of OCP where, OCP storage, etc., are also, and OCP security are working on different specifications called lock, safe, etc., that would help gain confidence on the secure wipe on drives. We will go a lot in depth in this first portion of data sanitization in JM's portion of the talk. The second thing ties into the carbon transparency that we spoke about. Of course, if we want to make sure that we have an assessment of how much carbon savings are coming out of reuse, or is there a carbon impact, a positive impact out of reuse, the first and foremost thing is that the carbon assessment has to be standardized and has to be accepted between all the bodies. So this directly ties to that first focus area of carbon transparency and carbon assessment reporting, which, like we showed, OCP is already trying to push for, is already trying to work on. The third one here is carbon accounting, which is the providing incentives to everybody in the value chain to enable drive reuse. And the last one that affects drive circular reuse is in storage, is being able to assess performance and lifespan of the device. Of course, there are multiple concerns in the reuse of drives, where not only with data security, but there is also an aspect of when you are reusing a device, you're basically deploying an older technology. Is that performance compliant? Is that going to be able to meet the needs of the current day systems? So this is another channel of work. OCP does not have an ongoing work stream on this particular aspect right now, but this is also very varied between different organizations, and depends heavily on where the reuse drives have to be applied. So what that essentially means is the performance criteria could be met by the reuse drives, just depending upon what is the application in which the reuse drives are being applied. Okay. So for the data sanitization part, which was the very first aspect that we pointed out over here, currently OCP is there is also a push in OCP for having a certification, a method by which we could say that these drives are reusable drives certified. And there are a lot of specifications out there in the industry. Currently, there is IEEE 2883. OCP has lock specification put out. OCP has safe specification put out, all of which are being refined. So with all of these different data wiping and data purging specifications, what OCP is looking to do is build on top of that. Build meaning provide a holistic view of which of these specifications would be needed for the drive to actually be called reusable. Which of these specifications coming together is essentially enough for the drives to be called reusable. For that aspect, we actually see that there are multiple paths of drive wiping. So OCP sustainability is looking to study each of these paths and put out what would be the requirements under each of these paths. So which one of these maybe require lock to be enabled? Which one of these would require encryption of those drives from birth? Which one of these requires a particular verification level? So that is the kind of holistic path or guidance that OCP wants to provide in this certification process, so that a user meaning somebody looking to enable the circular reuse of drives, can essentially pick one of these paths, check whether they are able to enable everything listed under that path, and say that, okay, as per this path, I could be called reuse certified. There might also be a requirement for enabling more than one of these paths of reuse, for providing more layers of defense and raising the confidence in data sanitization in the industry. So this is the work on data sanitization side in very, very brief that has been going on. Everything is in partnership with CDI. I would also like to call out another set of work by Microsoft in association with CMU University. This is a paper that actually calls for research on storage emissions particularly. And one thing that the paper shows is that of the total carbon cost, of all storage systems, 61%, which is a majority, is from embodied carbon. So this lays the emphasis on, being able to help embodied carbon, exactly like we saw in this particular slide. So this lays the emphasis and shows that this embodied carbon portion in storage nodes in Azure is about 61%. So it's a major chunk there. Going back to this particular slide, another thing that the paper also calls out is how much is the relative contribution of the drives in each of the storage systems. So you see the first table on the top that shows about 80% of the embodied emission coming from the SSDs in the storage rack. And in the second type of storage rack, in the table below, it basically shows HDDs contributing 41%, SSDs contributing 38%. So a majority chunk comes from all the different drives. And that again lays emphasis on the circular reuse of drives over here. After this analysis, the paper also calls out for various techniques for reduction in storage emissions. There is work that can be done with power, with lowering and also shifting the power usage times. There can be work done with deploying denser drives, and that, of course, applies in all kind of components. Deploying denser components can help per unit carbon emissions. But another two very important and interesting things that they call out is extending the lifetime of devices and considering a second life or recycling of the devices, which is, of course, aligned with the key aspect we are pointing out here, which is the circular economy. Okay, very briefly mentioning, one of the four aspects that we pointed out would affect circular reuse. So one of these four that we pointed out, the third one here, was the carbon accounting. And there is a particular need to address this. And the reason being, when we are thinking of circular reuse, the work actually starts right from the beginning of the entire value chain. Right from the materials, how the drive, how the IP is built, how it is manufactured, all of these aspects actually count into how much lifespan the device is going to have. So it is essential in OCP's view to be able to build incentives that would go back to everyone relevant in the value chain and basically incentivize them to do their part of the task. This is essentially the reason this work stream, also co-led by JM over here, has been kicked off in OCP, looking to see how incentives can be given in the carbon accounting. In today's carbon accounting methodology, we do not have any provision for this. So if there was carbon savings, it is only the end user who can estimate and maybe incorporate it in their carbon reporting. But essentially, we want to be able to see that there are incentives that can be given to everybody in the value chain, and also that there is a standardized way in which this carbon accounting can be done so that it does not differ from organization to organization. I will briefly mention the third and the last pillar of OCP's work, a little bit outside circularity. We had the third and the last pillar, which is around efficiency and efficiency of systems and power usage. So OCP has work going on that is to help not only power visibility, but also power metrics, sustainability power metrics. So they are currently working on defining a new metric that is IUE, infrastructure utilization efficiency, and also redefining or calling out some aspects of PUE, which has been, power utilization efficiency, which has been a pet metric for everyone for the past few years in data centers. The call out for PUE is an important one, which sort of says, if you see at the bottom of this particular slide, which basically calls out and says why PUE actually needs a determination at particular load, or there needs to be a call out of at what load PUE was measured, because that actually impacts the net value that you would evaluate for PUE. On the IUE side, it is working towards showing the split between computational and non-computational power within the IT power, considering that the computational portion of the IT power is actually the net and net useful for work portion. So there is this additional work going on with metrics about sort of bringing focus on what metrics should be evaluated and calling out anything with the existing metrics like PUE. And the last focus within this pillar is building a sustainability power profile. This is a telemetry profile, which is just adding visibility to the power usage at the device level as well as the system level. You can, again, if you subscribe to OCP from their website, you'll be able to get the links to review the templates for this power profile and the other documents that we mentioned also. And I will call out with that, this would be where you can go and subscribe to the OCP current work. With that, I'll hand it over to JM to talk more about CDI and the great work that they are doing for enabling circular economy.
Yes, thank you, Shruti. And I should call out, one of the obvious benefits of being in SNIA is, there's a lot of folks in SNIA that are kind of tying this all together. Obviously, we have the grain storage twig, and we have are working on figuring out kind of where we map the sustainability stuff. But SNIA has quite a bit of focus on data security and media sanitization. So that's one of the things you may see is we actually have a media sanitization page that's maintained. Yes, so first thing we're going to talk about is circularity. So as Shruti mentioned, carbon emissions, obviously these hyperscalers and large companies have net zero commitments, some by 2030, some by 2040, some later. And you'd imagine that these large hyperscalers are running massive data centers, that they'd have a lot of scope 2, which is purchased energy, emissions from purchased energy. But as it turns out, most of these hyperscale data centers are already on 100% renewable energy, and they've kind of eliminated most of the scope 2 out of their data centers. So you can see this is a Meta sustainability report from 2024, which shows their 2023 carbon emissions. And you can see these giant purple graphs. This is scope 3. And the scope 3, you can see it was over 8 million metric tons of CO2e. And most of that comes from this category 1 and category 2, purchase goods and services and capital goods. And when they're purchasing equipment such as CPUs and GPUs and SSDs and DRAM, a hyperscaler has to take the carbon emissions from the embodied carbon of what that took to manufacture that device as their scope 3. So this is obviously a problem because this is part of their value chain, and they have to figure out how do we actually reduce this. And if they've already done all the stuff in their power to reduce to scope 2, the only thing to do for scope 3 is to either work directly with the suppliers, and one of the strategies we'll talk about is circularity. Shruti mentioned this really great study, and I imagine it's not a very hard read. You guys should go check it out. This call for research on storage emissions from Carnegie Mellon and Microsoft Azure. But as she mentioned, this storage accounts for a large percentage of the operational emissions, which makes sense. If storage is a decent part of the data center infrastructure, then 33% of the operational or energy use would make sense. But 61% of the embodied carbon shows what I just demonstrated on that last slide from Meta, which is a large part of these emissions are now coming from the manufacturing of these devices. And it shouldn't be that hard to understand if these if DRAM and memory and NAND is being manufactured in places where there is not renewable energy, then the carbon emissions of that memory manufacturing will be high. Also, there is actually a large amount of scope 1 in memory manufacturing from direct emissions of F gases into the air from these manufacturing processes. So as we mentioned, one of the suggestions was to potentially have a second use and use extension to reduce the impact of the embodied carbon. It makes sense, right? If you manufacture a thing and you use it longer, then you're going to get less per year amortization on the embodied carbon. So one of the things that I am kind of disappointed with is I wish there was more better life cycle assessments for SSDs. There's one one study that was from 2023 that was kind of the dirty secret of SSDs, embodied carbon. And one of the things they found in the study was they did a meta-analysis of a lot of the LCAs that were out there for SSDs, a lot of which was embedded in things like Dell or Apple or HP or laptops or something like that. And they found that the embodied carbon of the SSD scale exponentially or with capacity, which makes sense, right? If the embodied carbon is coming from the manufacturing of the NAND flash, then that would make sense that a 4 terabyte drive would have 4 times the embodied carbon of a 1 terabyte drive. So I looked at the Apple sustainability report. They have an iPhone that has I think this was from the iPhone 15. And there's one model that has 128 gigabytes, one model that has 256, one model that has 512 gigabytes, and all of those have the same BOM besides the NAND flash. So if you just do some math, I did some math on meta-analysis of my own from the iPhone, from Macs, and from iPads, and the number I came up with was almost 60 grams of carbon per gigabyte of flash. And if you just look at the TAM of SSDs, and obviously the NAND flash TAM is about double this. If you look at what NAND goes into phones and USB sticks or removable storage cards and all that stuff. But even at the 2024 517 exabytes, that would be 31 million metric tons of CO2e, which, as you saw, all of Meta's scope 3 is like around 7 to 8. So this is an astronomically high number. And when I talk to people in the sustainability industry about this number, that is their first reaction is that this is a very high number. Okay, so how do we what guidance do we have today? So one thing that we have is there's some scope 3 guidance from semi. This is for all the semiconductor manufacturing, so this would apply to things like NAND flash and DRAM and other memory technologies. And so they have this section in here that's talking about focused, reused, refurbished, repaired goods. And the way that they have it defined is, basically guiding that if you reuse the device, that the second user, basically gets a benefit by not having the embodied carbon and the carbon emissions from manufacturing it, only from whatever carbon emissions were in that life cycle to do the recertification or refurbishment or moving the goods from point A to point B. As we kind of looked at for scope 3, this does not solve the scope 3 challenge for hyperscalers. It does, however, provide an incentive for using recertified equipment. And so I'll talk a little bit about some of the activities we're doing in Circular Drive Initiative. Circulardrives.org is the website. I mentioned a lot of folks. There's a lot of overlap between folks at OCP and SNIA. It is made up of hyperscalers, OEMs, storage vendors, and then ITAD and data erasure companies. And this is kind of new, where these are the members of CDI that actually are not generally members of SNIA or OCP. These are companies that are specializing in media sanitization and data erasure, and ITADs, this IT and asset disposition. So we have kind of a unique perspective because we're getting perspectives from boots on the ground, as well as the latest and greatest technologies, as we mentioned, coming from OCP and SNIA and others. So one of the things we did recently was write a blog post on this topic about how do we do carbon accounting for circularity and carbon avoidance. And the folks at Smith and Associates, who are a very active member in CDI, interviewed people from OCP and CDI members. So these ranged from hyperscalers to major OEMs to major storage manufacturers, and looked at key focus areas for their carbon reduction and carbon accounting. So I encourage you guys to just read the blog on circulardrives.org.blog. You can see the blog right there. The idea is that we'll eventually make this into a white paper, from OCP and CDI that describes when Shruti earlier this year had the director of the greenhouse gas protocol come into the OCP sustainability project and talk. and I think his name is Prakash. And one of the things he asked for was like, we want active feedback from people in the community, and especially in the ICT. We are experts in the ICT industry about, basically all things sustainability. We are living and breathing this industry, so they want feedback from us directly from the industry about how we would like to see things done in the greenhouse gas reporting standard. So this is one of the things this is one of the goals of this white paper. So as a preface, this is a slide from Marshall Chase from Micron, who presented with me at CDI in Firming Summit of 23. Just an FYI, the sustainability presence at my FMS 23 was not very high. We didn't have a ton of people in the sustainability track. So I'm glad that people are actively trying to learn more here and chatting with us today. But his example was, if we can extend the use period of the drive, say from 5 years to 8.5 years, so extending the use period by 70%, we actually may have reduced the overall supply chain greenhouse gas impact to this embodied carbon by up to 40%. So you have a reduction from the raw material and a reduction in the front end manufacturing. Remember, this was just one of the models. Obviously, the use phase, which you can't magically make the energy use of the drive go down just by extending the use. You're actually going to get, the more you use it, the more energy you use. But the embodied carbon for manufacturing, that is a one-time thing. So if you extend the use period of a drive by a certain amount of time, then you actually reduce the impact of embodied carbon. And this is on a per year basis. And so we put this, we have this carbon accounting and circularity work group and project in OCP, and Ari from Seagate and myself chair that. And I've talked to enough experts now to know that we really don't have a great answer for this yet. We mentioned what we use today is this, no carbon impact for circularity. And there's some people that feel strongly that, look, if you manufacture a device, it takes a certain amount of carbon to manufacture that thing. If somebody who has to use it, they need to account for it on their books and use it, put it on their scope 3. And so the obvious problem with this is that we just mentioned that ICT devices have high embodied carbon because these are not being manufactured primarily by renewable energy. So that's a problem. And this incentives this value recovery for circularity, which means if a user sells the device and gives it a second use, they can get value recovery. They can sell that device for a certain amount of money, and it's worth something after 3 to 5 years of use, which is good, but it's not enough incentive. It doesn't solve the problem of scope 3. So this amortization is the method I just described in that Micron slide, which is from a data center operator's perspective, if they can amortize that embodied carbon over the use period of the drive, if they, for instance, decide to sanitize the drive after 5 years and then sell it to a second user, that second user could take a certain percentage of the embodied carbon. And one of the things that Shruti mentioned was, the understanding of the useful life or useful use period of a device based off its quality and reliability. There's not really agreed upon things, right? Most of these manufacturers have a 5-year warranty. If you look on eBay and search SSDs, I imagine you will find many of the drives that I worked on when I was at Intel, 12, 13 years ago. They're still alive and kicking just fine. So obviously, devices don't magically just die at the end of 5 years. So this makes logical sense, and everybody we've kind of talked to about this method, it kind of says this kind of sounds like the right the right approach. Yes, okay. And then this last one is recertified products. And so this I mentioned, right now there was actually some companies, IT Renew, which is now owned by Iron Mountain, was one of the first companies to do a fully recertified rack of OCP, and this was really exciting. I know Sims is another company that is doing this through OCP right now. It sells a fully recertified rack, and if you buy that rack, you have a lower scope 3 emissions because you're buying recertified hardware that the first user has already taken the scope 3. So that's pretty cool. There's probably a world where some of these different options are applied to different customer scenarios. And I think that if you have a focus on scope 3 and you're buying carbon credits to offset that, then obviously scope 3 is very important to you. If you're purchasing new equipment and you want to have less carbon in your data center, I know a lot of folks in the EU. Like when I was at the OCP event in Lisbon, earlier in the spring, there was a ton of companies talking about this kind of like using I think OVH had an entire data center based off like recertified equipment. It was just amazing to see. And so there obviously is a benefit of having lower carbon emissions for recertified products. So I don't know the answer, but we will find it. So One of the topics of research that I worked on collaboration with a company called Interact, who's an ITAD and very, very active in the sustainability space, in iMasons and OCP, as well as here in CDI. And so they wrote this paper with me on this from waste to resources. And I'm really sorry. I probably should have put a link to the paper in the slide, but if you Google it, I hope you'll find it. So this was an idea of like, we're experts, us SNIA folks. If you're here at SNIA, you're probably a storage expert. And we know a whole lot about quality and reliability of storage devices. Like everybody, we at Intel, we shipped millions of units of drives, for each drive family. We know exactly the AFR. We know exactly the reliability for each firmware version. It's just definitely not a mystery. But there's a field of study about how drives fail that is just, a lot of these people that aren't in the storage industry think that it's like just black magic. Especially in hyperscalers now, where stuff like in the OCP and NVMe SSD spec, we have stuff like error recovery, telemetry, failure from SSD firmware, so you can basically format the drive and keep it going after a firmware failure. So there's been a ton of research and effort in this area of like how HDDs and SSDs fail. Meta came into the OCP storage project earlier this year and gave us a machine learning model that they had done on HDDs for predicting failure. And it basically jived with all the research we had, which was for mechanical devices like hard drives, if the more you use them, the more impact of quality and reliability you will have, because if you go over the rated wear limit, which they say here's the safe wear limit, they are mechanical devices and they tend to wear out faster, where SSDs have much different failure mechanisms. So this paper was an idea of like, how do we describe how this stuff works to people that aren't in the storage industry? And the other exciting thing was they just had basically a first party data from drives that they were sanitizing and decommissioning from some of their customers, and these were just all kinds of different drives and all kinds of different data centers and different scenarios. So they had records of this, 117,000 drives, and with some of the criteria we put together in CDI, which is this basically based off very deep knowledge of how hard drives and SSD fail and quality and reliability, they actually graded them 87% suitable for reuse. So the exciting thing that we have to announce is that we are going to have an alpha of this open source software and health grading algorithm. And again, this was helped authored by Seagate and others with some of the software tools that can actually grade a drive and tell us what health state it's in based off some of the log pages, smart, and so this is very encouraging, right? So 87% of the drives after, these are drives that are 5 or 6 years old were suitable for reuse. But the problem we call out is only, less than 10% of them are actually being reused, which where are they going? Well, Shruti mentioned most of the hyperscalers are shredding the storage today because of data security concerns and concerns with the quality and assurance that the data is actually sanitized. And so that is where we spent, as one of the main blockers of circularity, that's where we spent a tremendous amount of time in CDI. I'm also a member of the IEEE SysWig. And there, again, lots of SNIA members like Paul Stuhler and Eric Hibbard from Samsung are members of that SysWig and chair it. And we spend a lot of time and effort, making sure that the work in IEEE and SNIA and others are all being consistent. But in really what we're working on through IEEE is this 283 family of specifications. So I'll talk a little bit about the one we just recently published called 283.1, which is being voted on final draft right now and should be out here in a few months. And this spec relies on ISO IEC 27040, which is this all about storage security. And in there, it talks about IEEE 2883 for the sanitization. And there's also an example certificate of sanitization that can be used. And we'll talk a little bit about hardware roots of trust, firmware audits, and forensic analysis about how they improve confidence in media sanitization. So how it works today is if you wanted to use an IEEE 283 approved purge technique, the purge techniques today are overwrite, block erase, and crypto erase. Overwrite is obviously more suitable for hard drives. You don't need multiple passes anymore. A block erase actually uses the functionality of a NAND block erase, where NAND can erase programming pages but erase in blocks, and so this happens much faster than an overwrite. You can erase a whole drive, fully NAND erase, like programming the cells to 0 in 30 seconds to a minute. And a crypto erase happens in just a few seconds by you sanitize the drive by deleting the media encryption key, leaving all the data in ciphertext. So if you do this purge technique, this is often obviously just through the firmware of the drive. You can check the sanitize log. You can perform verification, which means you can read back all the data. And there's lots of new things happening in NVMe around this post-sanitize verification, and there's a new state machine and other stuff. But the easy way to think about this is you do the sanitize, you read the data back and see, is this the right pattern? Or if you write a known pattern to a certain LBA span, this is called partial verification. And then you do the crypto erase, and then you read that data back and make sure it's not the same data. When you're done with this, you generate a certificate of sanitization, and this is your legal get out of jail free card for, yes, this the sanitize has been properly performed by a technician. It was this software on the state and all that stuff that goes into there. The problem that generally may not be good enough for the level of security and risk management. The hyperscalers have been very clearly telling the storage industry, hey, that's not good enough for us. Like if we have any one bit of data or one drive hit eBay, that would be catastrophic to our reputation. It would cause huge reputational damage. It would cause great financial damage. Obviously, Morgan Stanley was a case study of this, which they had an inappropriate, disposition of drives, and that wasn't using proper media sanitization, and they had, data on the drives, and they had to pay a fine to the SEC, and all this is very bad. So we have a new spec called IEEE 283.1, and there's a nice little training I did on the Circular Drives website. You can find it's nice and free and easy to get there on IEEE 283 and 283.1. And I mentioned the spec will be out soon, but the spec is all about storage lifecycle, risk and management, cryptography. How do you choose the actual right appropriate sanitization method for the intended use of the storage media, like whether you're decommissioning it, whether it's going to a second user, whether you're sanitizing before provisioning. And then there's a lot of verification of sanitization. And the verification of sanitization is just another way of saying, like, how do you know that the data is gone? And that's obviously a very important question if you need to prove that that after you do a sanitization that nobody will be able to get to the data. And so in the spec, we have this nice table. There was a lot of debate on exactly how this table should be, configured, over these many hours in this IEEE SysWig work group. But you can see if you apply a sanitization method, clear, and then your adversary capability, novice. And in the latest version of the spec, we actually define what a novice, an expert, or virtuoso is. Novice would be like you're using off-the-shelf data recovery tools. Expert might mean you have some insider knowledge about how firmware works, how storage works, how plist and glist and all these things work on hard drives. Virtuoso would be like you have an unknown firmware exploit that or you are a like nation state level attacker. And by the way, this is virtuoso is what the hyperscalers are afraid of. They are afraid that somebody will steal a drive and it's going to be a nation state, and they will spend hundreds of millions of dollars to try to find a firmware exploit to find the some drive where it's leaking the root key, and they can harvest it to decrypt AES 256-bit encrypted data, which we say almost impossible for destruct, but very unlikely. It is, even with a virtuoso technology, purge prevents from almost all of these scenarios. The very, very unlikely scenario is the one I just mentioned, which is somebody finds some firmware workaround to basically harvest the root keys on a device to decrypt encrypted data. Again, this is very, very unlikely. And so if you think about this, and if you're making a policy around data security, and this is how in the spec we walk people through. Okay, if you're a customer and you are a user of data, first you have to classify data based on data sensitivity, low, medium, high. This is like table stakes in ISO 27040 about like how you manage data. Now, if you think about the likelihood of retrieving meaningful data, this almost impossible or unlikely. And then the magnitude of loss, meaning like if somebody were to, for instance, find that data, like how bad would that be? Well, I mentioned hyperscalers don't really care. If it's any data, then that's bad for their reputation. So they would classify all this, the magnitude of loss, as high. And so thus, if you apply unlikely, which is this purge media sanitization, you still get to a very, very low, impact of risk. And then in the spec, we talk about managing risk. Okay, well, one of the things to do is accept the risk. One of the folks in the work group says, okay, well, I get in my car every morning and drive to work, and there's some chance that I get in an accident. But it's really nice to have a car and get to work and not have to, take the bus or do another form of transportation. So that is accepting risk. So there's a way to understand that there's a very low percentage of risk and that you're accepting it when you do a thing. And this is exactly what we have to do when you're writing a media sanitization policy that makes sense. So how do we make that trust even higher? Well, one of the things that Dell presented out their media sanitization policy for us in CDI, and which is great for all the recertified stuff and all the equipment that goes back to Dell. I think that their policy is extremely reasonable. And one of the things they make their vendors do is they make their SSD and hard drive vendors have proof that they've actually validated the sanitization, which makes total sense. Vendors actually do this. They do a bunch of work. And so they just say, okay, well, provide proof that you actually done it on the latest firmware and that you tested it and that you're going to sign a form that says we guarantee that after sanitized that there's no data that's going to be exposed. Obviously, there's certifications. The IEEE 283 certification is not available yet, but there are companies like Adisa that are doing, trying to certify software and drives, that they are doing the right things that are in that spec for being compliant, and they will be one of the certification bodies going forward. So I know OnTrack is another one that does these kind of certifications. A third-party audit. So we're going to talk about OCP Safe, but this is, and I have talked to some of these people that do the independent firmware audit, but at the end of the day, if you're asking the question, when I send a sanitize command, how do I actually know that the drive did what it was supposed to do and remove the data? Well, the only way to actually know, because at some point you can read the data back, that's verification, but how do you know that data that's over provisioned data or data that was bad blocks, how do you know that was actually erased? Well, turns out the only way you can actually know for sure is to do a third-party audit of the firmware. So somebody a security researcher that does this for a living needs to review the firmware and find vulnerabilities. And this is exactly what the OCP Safe program does. The next level up is making sure not only are you knowing that firmware was audited, but you're running a known version of that firmware, this firmware attestation that is verified and signed by the vendor and and you can verify and attest that it is the right version and it is from the right vendor through a hardware root of trust. So all these things are things that help improve trust in media sanitization. And the big news was that Microsoft and Google have collaborated on this thing called OCP Lock. They've collaborated with storage vendors such as Samsung, Kioxia, and Solidigm. And there's a bunch of presentations. I forgot to add the link here in the slide, but if you go to the OCP Global Summit 2024 past events, you will find a talk from the folks at Microsoft and Google about OCP Lock. And this is a new technology, this layered cryptographic open source key management, which I'll do my best to explain it in 1 minute. So today, the way crypto erase works on drives is you have the media encryption key within the drive, and the drive firmware has a hardware root key. And when you do a crypto erase, it rotates the media encryption key. What the hyperscalers would like to see is not only an open source key management block where the firmware has been audited and it's part of this hardware root of trust, but they want the keys to live outside the drive. They want the user to own the keys and inject it into the drive to decrypt the data on the fly with the AES-256 engine. So this is just a different way of thinking about media encryption and crypto erase, where the key lives outside the drive, not in the drive. I mentioned OCP Safe audits, in which if you are an SSD vendor, you need to do an OCP Safe audit, and just say it is coming in the OCP NVMe SSD specs on being a hard requirement for OCP. And again, these vendors take this security and vulnerabilities extremely seriously. But the good thing is that they test media sanitization, they test all these paths in OCP Safe. So and then Calyptra is a hardware root of trust, and again, a hardware root of trust is things that do these attestation and verification that you are running known hardware in the right firmware and by the right vendor, and making sure that malicious code does not be run. So these are three extremely powerful technologies. I can't even do my best to explain them here, but I mentioned, thankfully, you can go to the OCP Global Summit 2024 presentations, and there is talks on all three of these topics. Okay, where do you join the efforts? We mentioned there's a lot of sustainability work going on in OCP Sustainability Project. There's a white paper we wrote about 1.5 years ago that talks about what is sustainability to the ICT industry. I encourage you to read that if you have not read it. It is a primer of all the things that we talked about today. And there's a little bit, Shruti mentioned, there's a lot of active projects in the OCP Sustainability Project that are going on. Of course, CDI, obviously that's near and dear to my heart. We're doing nothing but efforts in storage sustainability and circularity, obviously, as the name implies. And we're going to bridge all this together with SNIA here very soon. So we are talking to the SNIA management about how to collaborate on all these things. Like I mentioned, we already are collaborating on, like for instance, this webcast this morning, where the SNIA folks can learn about the best of things that are going on in the sustainability world. So with that, I believe that was it.
I would also like to call out to, SNIA is having a lot of work even in the power efficiency and how to test for how efficient your power devices are. They are putting out a test for that. So yeah, we are looking soon for having more collaboration between SNIA, OCP, and CDI, and helping this entire domain. Yep.
Yes, thank you for all the hard work, Shruti. I know it's like myself, I'm only a volunteer in the sustainability stuff. I'm don't have sustainability in my job title, but I'm encouraging other folks that if you are a product manager or an engineer, you don't need to have sustainability in your job title to care. You can join the work groups and participate, and that's some of the best participation we have is by people that are not that are engineers and they want to dig in and help. So. Well, we have a few minutes for some questions.
So there were some questions in the chat which we've answered. I think in the text, in the replied text, but just to briefly mention, I think there was a question about what percentage of hyperscaler data center storage is actually using renewable energy, and about emissions from renewable energy also. And now most of the hyperscalers, I think they have target goals within 2025 to 2030 for either directly or through renewable energy instruments using complete renewable energy. And yes, there are emissions related to renewable energy also, but I think how it's basically been is that there are so many other aspects of high carbon emission that those have been the priority, because renewable energy obviously drops the emissions by a large extent. So that's once we are using renewable energy, that's not been the focus area for carbon reduction.
There's a very good question about how, for instance, circularity, if longer life cycles and reuse directly competes with the sales of new drives, or would impact the the new markets. And this was I used to work at a company called Chia, and it was a blockchain that was invented to solve the Bitcoin energy problem. And the idea was to use hard drives instead of very super high power Bitcoin miners. And this was one of the emerging markets that would be a perfect use for reused drives and circular drives, because the idea is that the quality isn't really required. It's a kind of an application that's not storing a bunch of sensitive user data, so there's not really data security concerns. It's you don't care if the drive dies. There's no redundancy or reliability worries. So it's really a great market for being able to absorb stuff like used drives. What I've heard, and I just spoke with a ton of ITADs at this last SERI event I was at last week, and they were talking about emerging markets like China and India, and where they're selling like 1 terabyte and 4 terabyte hard drives. And I'm like, people are still buying those? Like, what are you? That blew my mind. I couldn't even fathom somebody buying a 1 terabyte hard drive right now, like with all the technology that's out there. But there are emerging markets that are willing to pay $5 for a drive or something like that. So the way we've described this, and the way I've talked to many of the vendors about this, is that these are different markets. The emerging markets, they're not going to be like your I mentioned the one, there are some cases where, maybe you have a tier 2 hyperscaler that's willing to take, hyperscale equipment from a tier 1 hyperscaler that was like 3 or 4 years old. But generally, the way I've seen most of these markets shake out is they're going into like emerging markets where they're just extremely cost sensitive.
Yeah, and to add to that, like James was pointing out, there might be at least a portion of this reuse might be into essentially new channels that are sort of getting created. So, and that's one part of handling the aspect where it is competing with new sales, is if it is actually creating some new channels that should help that particular concern. And the second thing is also in having carbon incentives, carbon accounting incentives, that is another place where this particular concern is front and center, is that we want to, in the industry, make sure that everybody in the chain are able to see the carbon savings or incentive coming from it, and it's not just the end user who is able to avail the incentive. So that should again help the folks who are facing this competes with new sales kind of issues, and that's basically the reason of the incentives. Sorry, JM, go ahead.
Oh, you're good. So I forgot to answer the second part of the question, which was about recycling. And there was a study on recycling drives, that have been shredded, and the problem is a lot of the rare earth materials like the magnets and they get mixed up with the aluminum or glass, and everything just kind of gets mixed up, and the energy it takes to sort through those is actually pretty high. And so it seems like a great thing to do with recycling, but unfortunately, it's not as good as it would seem. So one of the things that the hyperscalers are doing, and I forgot to mention, I wish I need a picture of this, and I probably should get one for the next presentation we do, but they have these machines that actually vibrate the hard drives, and then they disassemble the hard drives in the machine so that you can remove the case, from the magnet assembly, and then they can either reuse the magnet assembly or recycle the magnets and then just shred the platters. And then, is it as good as reuse? No, but it's much better than just blindly shredding the entire drive. So, again, this is most of the hyperscalers are already moving to deploying these at scale. So,
I see there is one more question that has come in. Will there be increased use of tape for storage due to tape using far less energy to store data? And yeah, I'm aware there are a couple of studies that are sort of comparing tape and other storage media and pointing this out in tape being more efficient. I think the net whether tape would be used more or less is not only getting influenced by how much energy it takes, but also the kind of performance and the performance requirement of the applications. So in this particular case, I would certainly say that it does heavily depend upon whether it's able to meet the requirements of that particular application. Right now, we have tape in a lot of the more archival kind of applications in many data centers, and it would certainly depend upon this particular speed or performance that can come from using of tape. So I would not say that pointing out of energy would alone be able to push the additional use of tape. I don't know, James, you have more to add on the question?
Oh yeah, no, there's obvious trade-offs of different storage technologies on latency versus cost versus sustainability, and yes, now this sustainability aspect is now being discussed quite a bit more as far as like understanding the carbon impact of different storage media and technology. So to say, if you are a vendor, doing life cycle assessments, following the work that we are doing in OCP around how to report that is extremely important.
Awesome.
All right. Well, thank you guys for all the great questions, and where to find Shruti and I on the OCP Sustainability Project list. If we're going to have probably a SNIA blog and a CDI blog, to follow up on any questions folks have. Again, there's a ton of great resources that we just had from the OCP Global Summit, where experts in all these fields, talked about all the latest in sustainability and storage security. So with that, thank you all and have a great week.
Thank you, folks. Thank you so much for joining us.
Bye-bye.